Welcome back to our series where we are learning SQL by going through it using the SQLite command line program and also somewhat in Python as well. So we're in video 3, and what have we covered so far? We've gone over installing and creating databases, all the data types, creating tables, adding rows, doing all kinds of viewing columns, adding columns. We've looked at adding new rows and new data, really all kinds of stuff, as well as adding additional columns and editing data that's already existing. We've looked at a little bit of conditionals and further specifying our queries, and a little bit at importing and appending external CSV data. And you can see how we kind of did that here, how we were able to import via CSV and essentially paste it right into a table that we already have. Now, what's going to come up next? We also went over deleting rows, and I did want to make note that earlier we said delete star from, which you can't do that with delete. I think this was the slide it was in, but you can't delete. Remember, star means all columns. Delete already knows that it's going to be dealing with an entire row, really. I mean, it's focused on the row. It's not focused on the column. It already knows it's going to be deleting all the columns for a row. So I just wanted to make sure that I noted that. But, okay, what's next? We are going to look at creating actual SQL files that we can run, essentially, if you wanted to automate some scripts rather than being in the command line and doing it yourself the whole time. We're going to look at using a separate database to write to a current database. So this is going to kind of be for when we create a backup for our database, which you should always do, especially if you're going to be deleting stuff like we will in this video. And we're also going to look at further specifying some database queries and really looking at how we can group and really adjust and tune what we're looking at from our database so that it's useful for a user later on. And here's just an intro of what we're going to be doing. Some command line programs. We're going to be using aliases and attaching databases, detaching, and some of these other specifications such as group by, order by, limit, and having. So let's stop talking and let's actually get into it. So our current database, this is what we have. And if you didn't follow the other videos, don't worry, because what we're doing right now is really going to give you a way to create the database that we already have. So if you're following along, what we're first going to want to do is create a backup. How do we create backups? What we're going to do is in our command line, so not actually in the SQLite program, we're going to run our smokers.db, so that's the name of our database, and we're running it using the SQLite3 command line program, so that's what we kind of queue it with. And what we're doing with that database is we're doing a dump, and followed by an arrow pointing to what our SQL file that's going to be made is going to be called, and that's going to be the createsmokers.sql. And so what's going to happen here? What we have is our smokers.db, and we're doing the dump on it. And where are we dumping it to? Look where that arrow is pointing. We're dumping it into this createsmokers.sql file, which we don't have yet. It's going to create it for us when we run that. And you can see after we run this command, we actually end up with this SQL file. And within that SQL file is instructions for how to create the smokers.db database. So it's important to note that this is not the smokers.sql. It's not holding the data itself. Rather, it is holding the instructions for creating the database. It's important to remember that because you may think you created a backup, but all you did was create your script for it. But if you created your script for it, you can use your script to actually create a database. And so the command for doing that is going to look very similar. We have the database that we're going to dump it into, which is the smokers underscore backup.db. This doesn't exist yet, but this is going to be what's created. And then the arrow operator, which is pointing the other way this time, because we're going from our SQL file to our database. So it's running this SQL file, and it is creating a database that will be called smokers underscore backup.db. And you can see here, after we run that, we have this smokers backup database, which is going to be identical to our smokers database. And what's really nice is because we created or we saved a script for how to make it, this script's not going to take as much storage as, like, let's say the actual database would itself. So it's very handy, like such as if you have someone on another operating system or computer, it may be able to get around the OS specifications because you're not sending like the binary. Remember, our database is actually in binary. You're not sending the binary to them. You're rather sending the SQL script, which they can run on their own machine to create the database. And so the binary is going to be compatible no matter where it's run from because it's going to be specified. Now, what did we just do? We created the SQL file that had the instructions. We ran the instructions in that file to create a backup database. And now let's hypothesize. Let's say that we did the unthinkable and we accidentally deleted our database. But luckily we have a backup. So let's walk through that. So we're going to go into our SQLite program using the SQLite3, followed by the name of the database we're going to be going into, which is the smokers.db. And let's drop this table. Now, if you're like an intern or a newbie at your job, you do not want to be doing this, dropping or deleting unless you know what you're doing. But let's do that because we know we have the backup. So let's just drop table smokers. And we can check that it's actually gone by running the .tables, which will, it's going to show what tables exist in the database. And right now there's nothing because we just dropped it. Now, what we can do is we can actually use our other backup database, the binary is what we're using, not the SQL file. We can use that to actually move that database back into our working database, which is the normal like smokers database. And to do that, we have to first attach this backup database, running attach database, followed by the name of the backup database that we're attaching. Right here. And we're introducing actually aliases here now, where we're going to say as backup. And so this it saves some like typing later on so that we don't have to write the whole entire name in that later on. We can just use backup if we ever actually want to use this database that's now attached. Now let's actually use that attached database. We're going to create a table. And remember, we are in our smokers.db. We are not in the smokers backup. We're in the smokers.db that does not have any tables in it right now. We're going to create the smokers table again. And aliases again as select star from backup.smokers. So what's going on there? We are selecting all columns, select star, from backup. Okay, that's the name of the database we attached. And within that database is a smokers table. So we're accessing the database and then dot the table name that's actually in that database. And it's really cool because we're seeing how aliases don't have to just be names, but they're really used for kind of almost copying and pasting, if you will, the data over. And so when we run that, it's going to basically take what's in the backup smokers database in the smokers table, and it's going to put it right in our new smokers table. And that's what's going on. So we're going to look, I guess I put a slide in here to look at it a little deeper and just kind of note how we said as select star from backup.smokers and how we're really doing an alias to a query itself. We're already seeing how these SQL statements can start to get kind of long and they can get very complex, but they do exactly what you want them to do. And all right, so after we add that table and we paste in from the backup database, we're all good. We can check. We have .table, or if we go .tables, we have our new smokers database now. And you always want to, once you're done using an external database, is you can detach backup. And remember, it's called backup because we use the alias. So we're good now. We're basically back at square one. And this is what our database is looking like. All right, what do we want to do next? I think that we should look at deleting columns. I don't like this column anymore. There's too many empty spots and I don't want to go through the work and classify them all. So let's look at deleting columns. So can we actually delete columns? It's a little more nuanced than that. We can't just say drop that column. It's not that simple, sadly, when it comes to SQL. What we're actually going to have to do is create an entire new table we're basically creating an entire new table that does not have that column. And in order to do that, we're going to have to do some copying and pasting again. So let's see how we would go about that. We first have to create a new table, which we're going to call our smokers temp. So it's like a temporary table for us, and followed by the column names for it. We covered this kind of creating table in the previous database. And in the smokers table, the smokers temp table, it's going to have all the same columns that we had here, except for that weight class column that we want to really delete. And then from there, we're going to have to, we just have an empty table right now. We're going to have to paste into our smokers temp table what is currently in the smokers table. And remember, we're not pasting everything in. We're pasting everything except the column that we don't want. So if this makes sense, is we're basically copying this into our new table. So everything except this weight class column. And then after that, we just drop the table smokers. So this is our old table that has the column we don't want. And we rename our new table we just made, smokers temp, to smokers. And now we don't have that column anymore. And you can see that right here. And we kind of saw here again how our select statements allow us to paste stuff in. So it's kind of similar to what we did earlier, just without hard coding the values. Remember in some previous videos, we would have done something like, I don't know, it would have been very similar. So we say all the columns and stuff. And we used to just say the values followed by, I don't know, just the rest of the values that were supposed to be in there. And instead of doing that and hard coding those values, we are taking what is already in another table. And yeah, I just wanted to kind of point that out, I guess. Moving on, let's look at what really is a query. We hear this all the time, SQL queries. What is a query? A query is a request for data from a database. So like when we say select star from tables, we are requesting all columns from this table in the database. And they can really, queries can really be used in all kinds of ways. And it's all about the implementation for how you use your queries and what you want them to actually do. And what we can have with queries is we can have what's actually called a subquery, which we already kind of saw earlier. But a subquery is just a query inside of a query. So we have a normal select star from, okay, and then we have our subquery right here, which is just another query. Select the patient ID column, the age column from the smokers table as S. So this is an alias as S. So what's in here is going to be considered S. And what we want to do is we want to go into what we just selected for our subquery and get where the quality of life is greater than 5. But wait, do you notice something wrong here? We cannot do that. because what we selected in our subquery, we're selecting from the smokers table, but we did not select the quality of life column. So we don't have access. SQL does not know what the quality of life values are. So we have to make sure to include the quality of life column. And once we do that, it's actually going to work. And let's kind of digest what is returned to us. So we have a patient underscore ID column and a quality of life column. And these quality of lives, it's going to be where it's greater than 5. It's only if the patient ID had a quality of life greater than 5. And we're selecting, remember here, you might be like, oh, we're select star. I thought, why are we not selecting all of the columns in our smokers table? It's because we did that subquery. We basically, with our subquery, we shortened what we're looking at. Earlier we would have said something like select star from, and this would have just been smokers. That's what we would have done earlier. But instead we use a subquery. We are not saying select from the entire table. We're not saying to look at the entire table. We just want to look at some certain and specific columns in that table. And you can think about when that might be useful is it's for saving time, and it can speed up your program. So instead of telling it to look at the entire smokers table, it says, okay, all we're dealing with here is the patient ID and quality of life column. So let's just look at the patient ID and quality of life column. Let's not look at the whole entire smokers table. That's what subqueries allow you to do. All right, what's a view? A view is essentially a virtual table that allows us to save what's called is saving views. And what these views are is it's somewhat similar to like if you were to create a table, but the big thing is these views are not like permanently saved. It's sort of like you are saving a query is really what's happening. You're saving a set of instructions for getting data. And what we've done here is we're gonna create a view called, let's change that name back, older smokers. So let's create a view called older smokers. And what this view is going to be as is the patient ID, age, and weight. So those are the columns that we're going to be grabbing. And it's coming from the smokers table where they have where their age column is greater than 50. And what we can do with our view, older smokers, is we can select all the columns from this view. And here, what we see is, looking good. It's just the smokers that are over 50, and we are getting the patient ID, age, and weight columns as we specified. And I really want to hammer in with these views is that this table right here, it's not being saved. And this view is being saved, but not as a table. Rather, it's being saved as instructions to get certain things from the table. A view is basically a saved query. And so basically, if we would have added another row to our entire smokers table, and we ran this again, we could potentially end up with 3 rows instead of 2 if we added a smoker that was greater than 50 years old. And that just kind of shows you how it's not saving the table or the binary. It's saving instructions for getting certain data. And this really starts to make sense why we might use views when we start thinking about summary tables, such as if we had a big table in a database and we wanted to view some summary information such as averages, max, min, and all that kind of stuff. We could call this view whenever we want, and no matter what happened to the database, no matter what was, if anything was added or deleted since the last time we called the view, the view is going to be updated for that information when we call it. So let's go through creating a view for averages. We're creating a view, name is averages. and we're going to use a average age column. So here, look, we're using Aliases again. And what this is this is a, what are they called? The aggregate function. We're using aggregate functions, which we're going to talk about very, very soon. But for now, just we're creating an average age column, a average weight column, a average quality of life column, average height, and we're doing that all from the smokers table. And what we want to do now to really see how cool these views are and kind of interactive, if you will, is let's first look at, ignore what's down here for now, but here, select star from averages. So we're selecting what's in that view. What we see is we have all these numbers, but let's say that we added another row since calling that view, which we're doing here. And then we call the view again. Aha, look, we have different average age, we have different everything, because the view, what's being calculated by this view is different. It's looking at a table that has a different row, has a new row that it didn't have when we called the view earlier. So I just wanted to include that because it shows how interactive these views are. All right, aggregate functions. We just talked a little bit about those. We looked at the average, but we have a lot of other aggregate functions such as count, sum, average, max, min, and distinct, which is, I guess, kind of an aggregate function. It's really not, but it's just used with aggregate functions. But let's look at what these aggregate functions will allow us to do and how to use them. So select, we're doing a select query. Count star. So star, we know that that has to do with everything. That really means all. So let's count all the rows that exist. That's what we're doing here. And we're going to call the column total patients from the smokers table. So what this statement, and all it's really doing is it's counting how many rows there are in our smokers table. And then let's look at the sum. Okay, let's sum the weight column. We're not looking at all this time. We're just looking to sum the weight column. And what that's going to do is it's going to add up all the weights in the weight column for each row. Select average, we already saw that earlier. It's going to give us our average height. Max, let's do that on the quality of life column. It'll return to us the highest quality of life, and you can also get it to return to us the lowest quality of life for that column. So these are pretty useful, and often they'll be used with when you want to count distinct values, such as here we say select distinct patient ID as unique patient from smokers. What's that going to do? It's going to select all the unique patient IDs, which is right here. Okay, these are all unique. We have 12 different IDs. And what we can do is we can actually count how many are really in this table by instead this time saying select distinct count, running our aggregate function on the patient underscore ID. So we're basically running it on this column right here, and we're counting, okay, how many are unique? And it's returning to us a table that just says how many are unique. And let's look at here what's going on, because I always think it's important syntactically to just look at some of the nuances and figure out why. So if we just ran, this is without distinct, we said select count quality of life from smokers. We get 12. Maybe we don't have to use distinct. What if we did select distinct quality of life from smokers, not using count? Okay, we're getting a bunch of quality of lives. That's basically the unique ones. So instead of unique rows, it's unique quality of life values. That's what we get here. And then we run select distinct count quality of life from smokers. We also get 12. So really, I mean, these two statements are both giving us 12. And I just kind of wanted to note that out because it's important to realize what is actually being returned to you and what's actually being counted or looked at. And you can play with that a little bit later. But really what's going on is count. The count aggregate function is essentially returning to us its own table. And then distinct is running on it. So distinct is just running on what count already returned to us. I hope that makes sense. I probably want to explain that a little differently later, but we'll keep moving on. All right, we're now on to group by. Group by is going to allow us to group data into unique tables before these counts are performed or before we select data. And notice how we're not using distinct here either. Let's go into select count star from smokers. We already kind of discussed that earlier. Let's run the same thing, but this time let's group by quality of life. And what this is going to do is it's going to look at, it's kind of what we did earlier, it's going to find all the distinct quality of lives that exist and essentially make new tables. So one table for if they have a quality of life of 4, another table if they have a quality of life of 5, and so on. And now that we have these tables, what we're going to do is we want to count how many are in each of these virtual tables. And that's what we're doing here. Where our final two columns that we're going to be looking at is we want to see, okay, we want a column with all the quality of lives. And we want the count for how many are in each of those tables. And let's see what that returns to us. Aha, cool. We got a list of all the quality of lives that exist. And thanks to our group by, including our count function that's counting what was grouped, we end up with all the quality of lives and how many patients or rows essentially are in each of those tables that were grouped together. And that's really what group by does, is it helps divvy up and split our data, and then you can use aggregate functions in that followed by it. We'll go into some more data science stuff with group by later, but for now I think that's all good enough to know. And here I just added aggregate functions on to it, where we could also look at the average age, height, and weight, and really see how the group by is essentially creating a bunch of virtual tables based on the quality of life, because that's what column we're grouping by, and it's getting us our averages. So you can think of this in terms of research. You have your like NULL, or you have your test. You have your test group, and then you have the group that is not being tested, such as, let's say it's a clinical trial for a drug. One's receiving a placebo and one's not. You could essentially group by placebo versus not receive the placebo and see the differences in data between the groups. That's really where group by is coming into hand, and when you would use it is for comparing based on criteria in order to do null hypothesis testing. Here, let's look at a longer group by statement and just some other cool stuff we can do. Here, we're actually calculating the average BMI. And you can see that we can even write these formulas right into it. So we don't have to necessarily save all these average BMIs. We can calculate them on the fly and group at the same time. And here we also introduce order by. So let's say you can kind of think of this. This is all going to happen first, and order by happens at the very end. It's just kind of like a little configurator, and we say order by descending, and it's going to show us in descending order the average BMI. And you could have also done ascending. And one other little thing I want to know is the limit statement. You could add on to the end of that is, okay, I only want to see the 3. I only want to see the top 3. So basically it's the highest BMIs. I only want to see the top 3 BMIs. Or if you were looking at like a social media post, you might use limit. Like if you wanted to create a feature where it wants to limit to the top 5 views in the past hour, it's basically running the same exact kind of group by, order by, and limit statements as we have here. And having is just another specifier. We include that here. It's just another specifier where we only want to see it. We only want to see and select the results if the average BMI is greater than 0.3. So that's just having and limit are just further specifiers for configuring what you're going to view at the end of the day. And here I've included a pretty, from ChatGPT, is a pretty interesting table that I think could help you guys with some of the syntax and getting down the order, because that's one thing with SQL. Like, if you don't know me, I'm not a big SQL guy, honestly. And it's because I struggle with remembering the order. And these kind of, this table really helps you out, seeing that you want to have your where statement always before group by, your from statement after select, order by. That's an important one to know, is that the order by has to come before limit, and having has to come before both order by and limit. All right, that was a pretty lengthy video, a lot of contextual stuff, but we're going to be really reusing what we just covered over and over again as we continue to go through this SQLite series. So if this was kind of confusing and all over the place, don't worry, because we're going to have all kinds of examples using what we just covered in the following videos. And some of these following videos, what are we going to cover? It's going to be, we want to deal with null data. That's a big thing in data science you have to deal with. Some constraints, looking at how we can relate two different tables and relate rows together. We're going to actually look at creating user accounts. And this is where it's really going to hammer in. And you're going to start seeing like the beauty of like SQL and how this all works, is when we create a mock social media database where people can follow other people. Users have their own table with their own profile information, but these profiles can be linked to other profiles because of their following or followers, stuff like that. You can also look at some cryptography stuff, which is becoming pretty important nowadays. So I hope you all stick around for these videos that are going to be coming later, and take care.